This is the notes for 1.3 scaling ratios. We're going to build off our idea of yesterday of mixing concentrate with water. Okay, so in our scenario, it says the ratio of concentrate to water in a mix for lemonade is 3 cups concentrate to 16 cups water. What fraction of the mix is concentrate? Okay, so there's an important thing there. When they say mix, they're implying that this is the total. Okay, so of my lemonade, I'm mixing together my water and my concentrate. So my mixture is that total. Okay, so if I had 3 cups of concentrate and 16 cups of water, my total then is 19. Okay, so then there's 2 ways we can look at that ratio. So 3 to 16 is what we consider our part to our part. Okay, because that's comparing the part that's concentrate to the part that's water. So in there, there's nothing with this total. Okay, the part to part was strictly my water to my concentrate. So that does not mean that the mix is 3 to 16. We need to find the total. Okay, so that 3 plus 16 is where we got the 19. That'll give us the fraction of concentrate to my mix. So that's what we described though as our part to whole. So in the whole mixture, we had 19 cups. So my concentrate was 3 to the total part there, which is 19. Okay, so if you want to, we can highlight it over here. So my part to part is the water to concentrate. The part to whole is when I do the concentrate to my total mixture. Okay, we have another example down here that's written a little bigger for us. So it says in the orange juice recipe, it calls for 3 cups of water for 1 cup of concentrate. So when I compare concentrate to water, that would be 1 cup of concentrate for 3 cups of water. That is considered a part to a part. However, anytime it asks for my mix, remember that's what we're calling the total, that would be a comparison of the part to whole. So 1 of my concentrate, and then if I added 3 cups of water to that, that would give me 4 cups total. Okay, so we see the difference there? I'm comparing within my mix the concentrate to the water versus whenever it's the whole, I need my total. So 1 plus 3 gave me a total of 4 cups for my mix. All right, so now let's try one. So my recipe calls for 2 cups water and 3 cups concentrate. So right now, I have 2 cups of water to 3 cups of concentrate. To the side, I'm going to go and write that's what we consider our part to part. I'm comparing the part of my mix to another part of my mix. So right now, I have no idea how many total cups are going to be in my pitcher. Okay. Then it asks us to also compare how many cups of water would I need if I had 18 cups of concentrate. So I can make a proportion. I don't know how much water, but I do know that I have 18 cups of concentrate. Okay, so just like scale factor, I put my sides that match, that correspond on top, and the other sides that correspond there on the bottom. So if I have 3 cans of concentrate, and we're trying to use 18 cans of concentrate, how many batches of my mixture could I make? I'm thinking times 6 batches. So if each individual recipe calls for 3, I could make 3 of those batches using my 18 cups of concentrate. So to go along with that, 2 times 6 would give me 12. Okay. Again, I made that proportion by comparing my part to my part. We did water to concentrate, so I used it exactly as is. 2 cups water to 3 cup concentrate. That'll give me an X number of water to 18 cups of concentrate total. There is another way though we can solve this. So I'm going to rewrite my proportion over here. So 2 water to 3 concentrate is like X to 18 cups of concentrate. Okay, so instead of doing scale factor, remember the other way is to cross multiply. So 2 times 18 is 36. 3 times X is 3X. I would solve for X then by dividing by 3. Notice I still get that same 12. Okay, So if you're not sure, I don't see an obvious scale factor of something to multiply the bottom part of my fraction by, cross multiplying will always work, and you can use your calculator. I multiply the diagonal, 2 times 18, and then by this diagonal, 3 times x. So we'd end up with 36, and then divided by my 3x. Okay, let's try another one. This one's a little trickier. So if we want to make 40 cups of juice, that juice is my total. So this time we need a new ratio. We need the part to whole. Okay, how many cups of concentrate would we need? So I know I'm comparing concentrate to my total. That's my juice. So for my original one, I had 3 cups of concentrate. 3 plus 2 is 5 cups total in my mix. Okay, it's very important there that you have labels, otherwise we may miss part of it. Okay, I wanted the concentrate part to my total. So now, if I want 40 cups of juice, that would be 40 cups total. I'm going from 5 total to 4 total, 40 total. How many cups of concentrate would I need? Well, I'm thinking scale factor. If each individual batch is 5, I could do times 8 batches to get me 40 cups total. That would require, though, 3 cups of concentrate, also getting taken times 8. So my answer is 24 cups of concentrate. Okay. Again, just re-emphasizing that there's a difference there. The water to concentrate was the part to part. If it ever asks you for the juice or the total or the mix, I have to write a new ratio where I've added those two together. Okay, so I'm going concentrate, so that's why I use the 3, to my total, which was 5 cups in my mix. The other way to solve, I'll go straight over here to the side. So we had our ratio of 3 to 5 equals x to 40. So if you don't see this scale factor, remember we can cross multiply. So I would take 3 times 40, and I would get 120. 5 times x is 5x. So to solve for x, we divide by 5. Okay, you can double check that in your calculator. So I have 3 times 40, I multiply those diagonals, and then divided by 5. So again, my answer is still that 24 batches. So same thing as last time. Okay. Part to whole is when I have that total mix.